Okay. So the question is, here's the core of a circuit. And we can use the plug and chug equations on our left if two things are true. If you can reduce the circuit down to a single RC or RL, and if the circuit is switched DC, meaning it was one DC value before time equals 0 and a different DC value after time equals 0. One of those two things could be 0, or they could be both non-zero. If they were both 0 before and after being switched, the solution would be pretty obvious. It would just be 0 all time. So the very first step when analyzing a circuit like this is to say, what method do we use? You see a single capacitor. So what order differential equation models it? Ben Wallace?
First.
So you know you're going to use a first order differential equation. And is it switched DC, Tim?
Yes.
Right. There's only DC sources, and there's definitely a switching component that happens at time equals 0. Tim, just to finish up with you, what position is the switch in before time equals 0?
It is down, so it's like
right
connected to the shorts. I guess it's not shorted, but it's on the one on the bottom.
That's exactly right. So Brian, first step with this. First step with any first order switch DC circuit is to do what?
Have we found V of 0 yet? That's what I was going to do.
That's exactly what you need to do, is to find VC of 0. And so in order to do that, you're going to redraw it for time less than 0. And the goal is to find VC 0. Don't skip drawing it. So Brian, for time less than 0, the switch is in the
downward position.
Down position. Do we want to draw, Brian, I'm going to stay with you for a second. Do we want to draw the left-hand side of the circuit, the right-hand side of the circuit, or both sides of the circuit?
You only need the left-hand side because it's in the down position. It acts like an open. So, I mean, right? Correct?
Right reasoning, wrong answer. What is it that we want to find?
Oh, are we trying to find tau?
VC naught.
VC of 0, yeah.
VC naught, yeah.
So where do you have to draw it to find VC naught?
The right-hand side?
Right
You got to draw the right-hand side, yeah. If hypothetically you were to draw this, although this is a correct picture for the left-hand side before time equals 0, it doesn't tell you VC naught, so it doesn't get you anywhere. So instead, now you could still draw it. There's nothing wrong with drawing it. I mean, it is
but
there.
It's unneeded. It's not needed because it's not even attached.
But it's not really attached to anything. Now let's examine, for those of you who don't see why it's not attached, why. Brian, just finishing up with you, what does the capacitor become for time less than 0?
It becomes open.
That's right. Capacitors become opens, inductors become shorts, and in this region,
0, right?
In this region, it's VC naught. That's right. So we need to find VC naught, and I didn't finish drawing this thing, did I? There we go. Okay. Why is that 9 volts not affecting anything? Josh, tell me why the 9 volt source is not affecting VC naught.
Can you repeat? Somebody came by.
Someone said correctly that 9 volt, Brian said that this 9 volt source doesn't affect VC naught. And I say, oh, come on, it's connected to VC naught. It's got a wire right there. Why is this 9 volts not affecting VC naught? Surely if we change that 9 volts to 9 kilovolts, VC naught would change, right?
Is it because it's not connected because of the open?
It does have an open, but it's got a short on the bottom. So doesn't that count for something?
I don't think it is, though.
Why not?
Because you don't have a circuit loop.
Yeah, it's not complete.
Yeah.
You don't have a complete loop.
You don't have a complete loop. Well, we've got a problem then, because we don't have a complete loop on the right-hand side. So does that mean VC naught is it got to be 0 too?
Yeah.
Correct. So what happens? But wait, but what if we're asking for the voltage across the switch? Once again, we don't have a complete loop. That's supposed to be a W there. Is the voltage across the switch 0?
Yes.
No, it's not. We need to ask ourselves, where is the current flowing in this circuit? And Lainey, tell me, where's the current flowing in the circuit?
In the left-hand side
Okay, so it starts off here, and then where does it go?
across the switch. And
Across
then-
this open?
No,
You can't have current flow through an open, so
No.
that's not going to work. Okay, so let's try again. Where does the current flow in the circuit? Grant, what do you think?
First through the bottom part.
Okay, so it flows through the bottom part. And does it go, maybe I drew it too much. Flows through the bottom part, does it go up here or does it go straight?
It goes up,
Goes up. Okay, and then where does it go?
right,
To the right. And then where does it go?
down.
And then where does it go?
I can't go there.
It can't go there. So all right, that doesn't work.
So just back to the voltage source.
So it goes back to the voltage source, and then where does it go?
Guess can't go there either.
Okay, so there's no pathway for for current to flow. There's no pathway for current to flow. And because there's no pathway for current to flow, currents everywhere are 0. Is that a problem? We're going back to all the way back
No.
to last semester. No, that's fine. So there's no voltage flowing. So therefore, what is the voltage across this resistor by Ohm's law?
0.
0.
All right, so we got 0 volts across here by Ohm's law. What's the voltage across the switch?
9.
9. So we don't know what this voltage is by Ohm's law. Right? Ohm's law only works for resistors. So we can't use, so just because there's no voltage across here doesn't mean that just because there's no current through it doesn't mean there's no voltage across it. So Shreyer, how did you figure out that there's 9 volts across here?
You have a 9-volt source and the other side is grounded.
Yeah, I would say it's connected by a loop. And so if you're going to do a KVL around this loop, you'd get -9 going up, you'd get plus V switch, and then that equals 0. So therefore V switch has got to be equal to 9 volts. So just because there's no current does not mean that there's no voltage, but it means you got to analyze it a little bit. But we're not asked to find any of those things. We're asking to find VC naught. So how do we find VC naught? Caleb. Our whole goal here that Brian said in the very beginning is to draw it for time less than 0 and find VC naught. And we've been kind of fooling around and finding everything except for VC naught. So how do you find VC naught?
VC naught is the open between the 9 and the 100K, right? So
VC naught is this.
oh, okay.
It's where the capacitor was just a moment ago.
VC naught is 0
Why?
because it's just one loop. It's just connected back to itself with a resistor in between.
Right. So what you're doing is you are doing a KVL around here. And that KVL says that entering here plus VC naught, and then there's no voltage here, no voltage here. We already said this has to be 0 across this resistor because there's no current flowing through it, equals 0. And that's why VC naught is equal to 0. So that's a important result. I'm going to rewrite that in our
Yeah, if
standard
there's
colors.
no current, it can't be voltage.
Oh, you were so right up until you said that.
Oh.
If I gave you a 9-volt battery, a 9-volt transistor battery, not connected to anything, how much current's flowing? I just handed it to you. It's not connected to anything.
No.
Nothing. Is the 9-volt battery a 9-volt battery? Does it have 9 volts across the terminals?
Maybe.
Assuming that it's not a bad 9-volt battery. I gave you a good 9-volt battery.
Yes.
Yes. So can you
Yes.
have voltage and no current?
Yes.
Absolutely, you can have voltage, no current. We just showed it over on this side that there's 9 volts across this switch, even though there's absolutely no current flowing through it at all. So not having 0 voltage does not imply 0 current, and having 0 current does not imply having 0 voltage, with one exception of one component where it does require that. And what's that one component?
Resistor.
Resistor, because for a resistor, there is there is this relationship. So only for resistor, 0 voltage means 0 current, but not for anything else. Definitely not for a battery that's just sort of hanging out there, where not connected to anything, 0 current, 9 volts, doesn't cause any problems at all. All right, so getting back to our problem now, we've now pretty much killed this first section. We've definitely agreed that our goal was to find VC naught, and we